Okay, I will try to keep this super quick. Do you see this path here? I improved the system, so rather than following it, and but then because of the buildup of gravity, not being able to follow this part in time, and then we fall down, it now does this much more beautiful. You can even see it here, not very much though. Moving on, double jumps. You saw it happen there. Here's another example of it happening over obstacles. This is supposed to represent fog. Here's of another example of it skipping a whole bunch of and here and here's another example. Rather than going around and whatever, you can just jump here and save a lot of time and reach the player quickly. Here's how the normal graph looks. You have start connections. These connections are basically from primary to fallback, and then we have finish connections, which are from fallback or air nodes, as you want to call them, to primary. Now, if you're interested in the technical side, I will go over that quickly. Essentially, we generate the start connection from primary to every fallback node. At the same time, we generate from every fallback node to primary these finish connections. Now, all the start connections are going to random nodes such as these, but don't go or don't have a jump connection to a primary, they get removed. Same for finish connections that have a jump to a primary, but don't have a primary jumping to them, they get removed. And then obviously we will have a bunch of, from primary to fallback nodes here going to primary nodes, but then we only choose the cheapest chain and we keep that cheapest being the shortest distance. That's how we can tune down the chaos in the graph to something like this, which is still a little bit chaotic. So the path generation using a graph with double jumps, the cost of that during runtime can be a little higher. Now for triple jumps, it's much, much higher. Here is what it looks like for triple jumps. Ignore the yellow, there is an issue with the system that draws these. I could not be asked to fix it. Yellow essentially represents a mutual connection, which is not something necessary here. So yellow could be either a start and a finish or a start and whatever. As you can see, this is kind of a lot. I've only added pruning for double jumps. Triple jumps have not had pruning. That's why generating a path for an agent with the ability to triple jump can be kind of laggy during runtime. Now, triple jumps will require a lot more pruning, but as you can see, there is still some pruning. Now, this pale connections are from fallback to fallback. So we generate finish and start connections just like we do when we generate for double jumps, except here we generate from fallback to fallback. However, if these fallbacks have no start coming into them, or when they connect to another fallback, that fallback, or when going into a fallback, that fallback does not have a finish connection, they do not get placed. Such a connection would not be generated. That's why there's a lot of empty space. Of course, this sheer and insane amount of connections makes the path generation, as I mentioned, laggy. I will show a runtime example now. It's very beautiful, but as you can see, it can be up to 100 milliseconds to generate a path. It even took up to 290 milliseconds here. which is just unrealistic. It is kind of nice looking at triple jumps working successfully, but again, this is simply, this cannot work. This triple jump was pretty cool though. The multi-jump system of course works for enemies with all shapes and sizes. As you can see, that's a double jump and not a double jump, and this enemy is 2 by 2 tiles. And of course its pathfinding works wonderfully. It can basically go as it should. Very nice. A lot of improvement has also been made to the placement of the nodes, the fall connections, such as the cyan one. Everything is much more accurate and efficient. The traversal becomes smoother. Other than that, there might have been some small fixes, which I can't remember at the moment, but that's about it. Thank you for watching.